The SGE DataArtist is the first choice if the task is to visualize and analyze big amounts of measurement data. Data can be loaded from various file formats, for example MDF files, text-based files, spreadsheet files, indication files, HORIBA emission test bench files, and all files can also directly be loaded from zip-compressed files. It is possible to select multiple files at once. They will get concatenated automatically. Depending on the file format, different options are available to influence the data loading routine. For example, the access ranges to load can be specified, a sample reduction can be applied, and the data loaded can be forced to have a common access. The channel names to load from file will be asked, and here we can also add calculated channels that allow to modify the data before loading. In this case, we add a calculated channel, for example, to calculate the vehicle acceleration from the vehicle speed. Finally, besides some other options, we have the possibility to define the axis to display the data against. Usually this is the time axis of the measurement data, but we also have the possibility to create an XY view here, choosing another axis. The data loaded in one turn is called a file set, and as we have seen, this may consist of multiple files data. It is possible to add as many file sets as needed. In this case, we add another file set with a measurement from another lab. Most options are pre-filled automatically for this file set. Finally, we have the possibility to automatically match the two file sets using, in this case, the vehicle speed, assisted by an optimization algorithm. As we can see, this results in an overlay of the two file sets, but we also have the possibility to manually match the file sets if we want to. As a special feature for combustion analysis, we have the possibility to automatically load indication I files in parallel with the engine management system measurement files. The crank angle-based I files are automatically calculated to the time-based system of the measurements from the ECU. This way we get a synchronized view of the ECU measurement data and the indicating measurement data, completed by an additional channel showing the crank angle position. Returning to our lab comparison, we can enjoy the numerous features to quickly adjust the view to our needs. Additionally to a complete configuration dialog that allows to modify the attributes of the channels displayed, we have the possibility to access most features using keyboard shortcuts or the mouse. For example, we can quickly set the display range of the channel to different sections of the screen, or we can just scale all channels to fill the screen. Using the mouse allows some fine-tuning. Channels can be assigned to group axes and therefore will handled together. Data analysis can be done using cursors. It is possible to add as many cursors as needed to a diagram, and the cursors can be configured using different options, for example to show differences, relative differences, mark common axis, sort or not sorted, and we have a feature Smart Update that allows us to update the cursor values only when the cursor is not moved again to speed up performance. The overview section at the bottom allows us to survey where we are moving inside the axis ranges. The axis section visible will be marked in the overview, and we have the possibility to add additional sections in the overview directly and adjust the view accordingly. Any of the channels loaded can be added to the overview. If the data loaded contains GPS signals, we have the possibility to activate a GPS view that will also show the cursor positions. Some data post-processing can be done using a channel wizard. Different algorithms are available. In this case, we use a moving average filter to smooth the signal. It is also possible to analyze the data using FFT or histogram plots. Extended data analysis is enabled using so-called marks. These are sections of the data that can be handled separately. Besides the possibility to draw marks with a mouse, there are some assisted methods available. So, for example, we can split a section into equal parts. Or we can classify a signal using marks with a given data span. A more advanced method to detect marks is the ramp or step detection. This method allows to detect, for example, rising ramps, constant phases, or deceleration phases inside a measurement automatically. In this case, we fitted a map to this acceleration. Finally, we have the possibility to detect marks using a logical condition. This is a very efficient way to detect marks, in this case, for all full load sections with nearly fully open throttle position. The DataArtist does not only allow to load data from file, but also to save to files. This may be done to save only desired sections to a file, or to reduce the channel number in a file, or to do a statistical analysis of sections of the file. So we can decide here which channels to save to file, which target format the file should have. It's possible to save to MDF files, to text-based files, MATLAB files, or spreadsheet files. And we can say which sections of the file should be saved. This could be the marked sections, the unmarked sections, the screen view, the whole loaded file, or as a special variant, a statistical analysis of the marked sections. In this case, for each existing mark, an analysis will be done and we can select which statistical results we want to calculate. Besides the standard statistical calculations, we also have the possibility to do a curve fit inside a marked section and to export then the results of the curve fit, so for example the polynomial coefficients, to the file. The resulting file can then be used to do further analysis and evaluation of the data. To show a more enhanced example of data analysis, we will now have a look at how to evaluate ignition sweep measurements to calibrate the torque model of the ECU. We have already loaded a measurement where the ignition angle was retarded automatically, leading to a decrease of measured torque, and each ignition sweep is indicated by a digital channel. In the first step, we detect logical marks for each ignition sweep. This is just done by selecting the areas where the digital channel is true. Afterwards, we split each single mark into a number of smaller marks and activate a special feature, the section optimization. Section optimization means that from the marks created, only the best one is kept. And the best one in this case is where the maximum of the mean value of the engine torque is available. This is done by applying a one-day polynomial, and we just keep one mark then near the optimum. Additionally, we will be asked which is the parameter channel. This is the ignition angle in this case, and we have some additional options available. Now the optimization is done, and for each section the data will be fitted using a one-day polynomial, and the view for each section is shown. After the optimization, we have for each ignition sweep evaluated just one small mark left, and a near of the optimum torque, and some additional channels were created indicating the optimum ignition angle and the optimum torque for each ignition hook. Again, we have the possibility to save the marks to a file and do the further data processing and map creation. For documentation, presentation and printing purposes, it's possible to create a so-called copy figure. The content of a copy figure can be copied to an email or document software. Before copying, it's possible to modify the figure. So for example, we can delete objects, we can rearrange objects, and we can edit objects. For example, we can change the line style of the red line. It's also possible to add additional objects. In this case, we use a text error to highlight some sections. Again, this object can be edited, and we can modify the text in this case. After finishing the figure and closing it, the content was copied to the clipboard, and we can just insert it into an email. The SGE DataArtist allows to save so-called session files. The session file contains all data loaded and the whole view configuration, and allows to continue the work to a later point of time or transfer it to someone else. It is also possible to save a template file. A template does not contain the data loaded but just the view configuration. So it's very small and can be used to restore a configuration to a later point of time by reloading the data. The SGE DataArtist enables the calibration engineer to efficiently handle the amounts of data accumulating in a today's calibration project.